The aim of this lecture is to analyze how regulation can be reconciled with the right incentive for investments and innovation in energy markets. After this lecture, you will understand why there is a trade-off between regulating an industry and fostering innovation, with reference to the case of renewable energy and smart grids for the green economy. Regulation and innovation are often considered to be contrasting policy objectives. Why is that the case? In the previous lectures, you studied that one key goal of regulation, at least in the short run, is to increase efficiency by mimicking competition in industries characterized by excessive market power. This goal, however, can conflict with increasing long-term social welfare through investments in innovation. Firms that undertake large innovative projects must sustain substantial financial costs, face risks and uncertainties in the outcome of these projects, and they are bound by the reversibility of the investment decisions. For these reasons, highly regulated settings may stifle investments in innovation. In the context of energy markets, the trade-off between regulation and innovation is particularly relevant. In recent years, the increasing adoption of renewable energy sources, along with other technological innovations such as smart grids for electricity distribution networks, has spurred a large debate among policymakers on how to regulate the energy industry. However, it has also encouraged the generation and diffusion of innovative technologies. Within the European Union, the policy debate is directly linked to the target of moving towards a low-carbon economy. In the Horizon 2020 program, the EU sets a binding legal objectives at 20% reduction in greenhouse gas emissions, 20% increase in renewable energy generation, and 20% higher energy efficiency. By 2050, the long-term energy strategy is to achieve an 80 to 95% reduction in greenhouse gases and a share of renewable energy of 75% in the final energy and of 97% of all electricity consumptions. All these targets are relative to 1990 levels. Renewable energy sources are one of the most significant innovations in our energy markets. They are more affordable than traditional fossil fuels, and they make electricity cheaper as the technology for solar, wind and other renewable becomes better. Crucially, they are cleaner than fossil fuels in terms of climate change damages, because energy from renewable sources generate less CO2 emissions. Finally, energy production is differentiated, which means that it does not depend on a single source like oil, and that is less geographically concentrated. Therefore, the paradigm for energy production using renewables requires different market structures compared to the existing ones. Rather than a centralized system, generation can become distributed and dispersed. However, renewable energy leads to several challenges. The main problem is that most renewable sources have an intermittent nature, which means that they are not continuously available. As a consequence, energy generation must be structured at a level of overcapacity. At the same time, during peak production times, it may be necessary to curtail energy production to avoid overloading the grid, and this reduces production efficiency. In general, intermittency implies a greater unreliability of energy outputs and a difficulty in forecasting energy availability, as most sources heavily depend on weather conditions. A second important technological innovation reshaping the energy market is the introduction of smart energy grids. These are defined by the European Commission as electricity networks that can cost-efficiently integrate the behavior and the actions of all users connected to it, generators, consumers, and those that do both. The main purpose of smart grids is to ensure an economically efficient and a sustainable power system with low losses, high level of quality, security of supply, and safety. The Joint Research Centre keeps a database of all smart grid projects in the European Union. In 2017, there were 950 projects and almost 5 billion euros invested in smart grids. As you can see in this map, demonstration projects in red account for a larger share of total investments than R&D projects in green. The only exceptions are Denmark, Finland, Norway and Switzerland, which have dedicated research programs and funding schemes. Given the importance of generating and adopting new innovations in energy markets, many countries have introduced innovations incentives into their regulatory mechanism for the energy markets. The United Kingdom's Revenue Innovation Incentive and Output (RIO) model is the best known example of a policy that effectively integrates regulation and innovation. Current concerns about innovation and sustainability have been addressed with incentives that focus on outputs measures of companies' performance, measures of network reliability, environmental impact, customer satisfaction, ability to meet social obligations, and so on. That example has been followed by several other countries such as Italy, Germany, and France. The RIO model has been a precursor of the new incentive schemes for innovation, with many effective features. Among the others, it's worth mentioning well-justified long-term context of business plans, long-term primary outputs to be delivered in the price control period, secondary deliverables linked to the primary outputs delivery in the future, time-limited innovation stimulus package, longer price controls, 8 years. In conclusion, to both implement efficiency measures and foster innovation, regulation of energy utility is becoming increasingly complex. Nowadays, policy design is simultaneously focused on expanding the regulatory period to guarantee more incentives for efficiency, including ad hoc incentives to invest in innovative projects.